Welcome to today's video. Today we'll be going over how to calculate area and volume of shapes. I'll go over shapes. There we go. Okay. I'll go over like the traditional ones to review that they'll most likely cover on the ACT. So, first I'll cover the area of most of your traditional 2D shapes, then we'll transfer over into volume of 3D shapes that will most likely be used on the ACT. So we'll first start with squares and rectangles. Squares and rectangles, the area formula is base times height or length times width. Whatever you like to use, either way works. So we'll just give it a practice problem, say given that what's the area of a rectangle with by 5 by 7? Well, 7 by 5 is 35. For a square, if you have a length of 5, remember, squares have all equal sides. So, each side length is going to be 5. So, 5 times 5 is 25. Then it'll be all in squared units, or in this case, units squared or whatever. The next area will be a triangles, which is half the base times the height. Or some people may write it, it is base times height over 2, because if you put this over 1, 2 times 1 is 2, 1 times this full thing is just base times height over 2. So, given that the height is, we'll say 8, and the base is 6, calculate the area. So, we know that 1/2 times 8, I'll put it over 8 over 1 times 6. Well, 1 times 8 is 8, 8 times 6 is 48. 48 over 2 is 24. So there is your area of that triangle, is 24 units squared. Trapezoids. Given, it's a nice trapezoid, you have a top base and a bottom base. We'll call this, you can call it base 1 or just top or just A. I'll just call it A. We'll call the bottom B. You can call B2 bottom and say T plus B, but that'd probably be confusing, or B. Then you have your height. So, the area of a trapezoid standard trapezoid is half times the added length of the top plus the added length of the bottom times h, the height. So given that the top length is 5, the bottom length is 9, your height is, let's say 3, calculate the area. So, once again, you plug it in, basically 5 plus 9 times 3. So, remember, orders of operations, you have to do the stuff in the parentheses first. So that is 14 times 3 times a half. You can put this all over 1 and say that 1 times 14 is 14. 14 times 3 is 42. 42 over 2 is 21. So the area of that will be 21 units squared. Now let's see if I can draw a fancy circle. That's circular enough. Circle. There's a lot involved with a circle that they'll do. You have to know the circumference. What does it say circum for short? I can't spell. You have to know radius, diameter, area. Alright. So, we'll go over each one. We'll start with the radius. Radius is basically from the center to the outside of a point of a circle is the radius. So the inside circle to the outside. The diameter, which I'll put on a different circle so it's easier to see, is from one side to the circle to the other side circle through the center. It has to be through the center, otherwise it's not the diameter. Otherwise, you would, for those who technically want to know, it's called, if it's not through it, it's called a chord. So, your diameter will be this. Right here, your radius is from the center outwards. And is right here. So, how you calculate your circumference of a circle is, you can think of it two ways. You can think of it as the diameter times pi, or you can think of it 2 times the radius times pi. Because once you think of it, if you double the length of the radius, it's basically the diameter, and once you times by pi. Now the area of a circle, which most of you may recollect, is pi r squared. Fancy pie. It's good with whipped cream. Anywho, we'll do a problem solving for diameter and the area. Given that the radius of a circle is 3, calculate the area of the circle. So, area is radius squared, so you can say it's 3 squared times pi So in short, it's 9 pi. If you want to calculate the decimal of that, which most likely on the ACT you're most likely not, but you might, is 28.27 units squared, because it's the area. Now if we calculate the diameter, and we'll use the same thing as that. 2 times the radius is the same thing as going from here to here and going from here to here, which is the diameter. So you can say that 3, say that's 3, and this is 3, so it's 3 times 2, or 3 plus 3 is 6, so you get 6 times pi is your circumference of a circle. And if you want to know the decimal approximation for that, that is 18.85 rounded. Now as we go into volume, the major ones you have to know is a cube, of course. Let's see if I can draw myself a decent cube. That's a decent cube. A rectangular prism. Let's see if I can draw myself one of those. Decent. We'll start with those two. So, it's the same formula for both of these. Is length times width times height, or you can do which is the easiest way to do it. So here's your base, here's your width, here's your height. You may call it like your base, your depth times your height. So there's your base, there's how far you're going back, which is your depth, and there's your height. So let's say that for this one it is 3. Well, a cube, it has all equal sides all the way around. So you could say that it's 3 times 3 times 3, which is also equivalent to 3 to the third, because that's basically what it's written out in extended form. So 3 cubed is 27 units squared. That'll be your volume for the cube. Let's say that you have a rectangular prism. That's not really rectangular prism-ish, but it's a box shaped, and having some cereal or something, and you randomly measure the box, because I don't know why you would, but some people do it. And we'll say that this is 6 by 3 by 2 units, inches, whatever you want to call it. So using your formula of length times height, or base times depth times height, whatever, this times that times your height, 6 times 3 times 2 gives you 6 times 3 is 18 times 2 is 36, or you can do 3 times 2 is 6, and 6 and 6 is 36. So, both ways, however you calculate it, the volume of that will be 36 units squared. Sometimes they may ask you, given the volume, let's say, we'll just do a cube because I can draw it decent. We'll say this is a cube. Given that the volume is 100, volume is 125 units squared, and the length of the side is 5. What's the width? What's the width? So you know that is, all these are equal, and this is equal there. So technicality, like this one, it's something cubed. So 5 cubed is 125, so in this case it'd be 5. But most of the time they wouldn't give you that. We'll just say they give you a rectangle box and say, given that the volume is 54 and the length is this and the height is this, what's this? So you just do the exact opposite and just divide everything, because all of these will equal the volume. So you take the total volume divided by this times this to get you the height. In short, times 8 divided by 2. It's a very odd height, but it's 3.375, we'll say. Next thing that most likely go over is a sphere. I'm terrible at drawing spheres, but we'll just say this is a sphere-like thing, which actually doesn't look too bad. Imagine it in your head, it's like a basketball or something. Some sort of ball-shaped thing. The equation for a sphere is 4/3 times pi times radius cubed. And all they'll give you is, say, the radius of it to this point, because it'll lack depth in here. When they'll say that the radius of this sphere is, we'll say, 4 is the radius. So all you have to do is, what's the volume of that? You just plug in 4/3 times pi times radius cubed. Most times I'll keep it in terms of pi, so you don't have to multiply by pi. In this case, r is 4, so 4 cubed times 4/3. I believe, double check, see if I didn't math the fraction, or I mean math the decimal. There we go. And you get 85.3 repeating pi. Pretty simple there, and most likely they'll give you, say, a can, saying they're giving a can of soup or something, I don't know. A can to put your ball or tennis balls in, I don't know. A canister of some kind. They'll give you a cylinder, and basically it's the height and the area of a circle. So, which is pi r squared. So basically it's pi r squared times the height is the volume for that. They'll give you the height will be, let's say, 5, and the radius will be 2. So that would be 5 times 2 squared times pi. 2 squared is 4. 5 times 4 is 20 with the pi. So it's 20 pi if anybody's really wanting to know what that is in decimal format. That is 62.83. all these, I just realized all these are units cubed, because they're cubed figures. And sometimes they'll give you a cone, get you like an ice cream cone. I'll just kind of make myself a waffle cone here. There we go. There's your cone. And all you have to know is basically your circle times by 1/3 of your circle equation, which is pi r squared, times the height. That'll give you the radius. We'll say it's, again, 2 is the radius. The height equals 4. Then you just plug in it in your equation, get pi 2 quantity squared times 4. So let's get this up. 4 times 4 is 16. 16 divided by 3 is 16/3, which is 5 1/3, or 5.3 pi. If anybody's really wondering what that is, it's 16.75. So you don't stress out, I'll write something. ACT gives you formula on most of all the formulas for 3Ds, or even the areas from before, will most likely give you an equation. The only one I think you might have to know is this. If you know how to calculate an area of a square and a rectangle, that's a have to know. Everybody should be able to know how to do that. Possibly a triangle, possibly a trapezoid, and a circle, which is pi r squared, and possibly the diameter and that stuff with that. But all the volume stuff, ACT will give you a formula of how to do that, because they don't expect you how to memorize it. So that wraps up today's video. I hope this helps you out. Please like, comment down below any other videos that you'd like me to go over concerning ACT, or just random math concepts in general. Subscribe to the channel. I hope this is a great help to you. I'll see you next time.